Hey everybody. So I have iterated quite a bit on BartPhi, and I now have BartPhi 2.8, which is a usable model and a model that is an improvement in at least some areas on both models. It's a significant improvement on tiny stories, and then an improvement in some ways on the Phi 1.5 model, which was kind of like my goal with iterating towards building out an LLM model in Colab. So just going through the code here first, really straightforward. There's a lot of pip installs. So pip install transformers. This is you have to install this if you for the Phi package, Torch packages from Torch. Pip install upgrade because I was running into a lot of issues just with various updates with the code, and then this gets you into the actual model. And then so up here, up front, you can adjust the hyperparameters of the model, so temperature, top K, and repetition penalty. You can also adjust the lengths of the different prompts down here, but up here you can adjust the essentially like the temperature. And then so it loads in the two models, the Phi 1.5 and then the Tiny Stories 33 million parameter model. And then essentially what it does is it initiates a loop, and then so it first relies on the assistant to generate the story, and then the Phi model cleans it up. Then it goes back to the assistant, and then finally the Phi model produces the final result. And then I've adjusted like the varying links, and then I also I have the Phi model as the decoder. If you put the assistant model as the decoder, the outputs are a lot worse. So again, like it's 2.8 because I've iterated quite a bit to get it here. Oh, and then the other thing is that it's all loading to GPU as well. So no resources, no resource issues whatsoever, and a good free Google Colab environment. Like I could do a ton more here without like any issues whatsoever. And then this is just a loop, real straightforward loop. It's just I input it and then it goes back. So my input, then the assistant model, then the Phi model. And then I've been experimenting around like with the different texts. Like so, I think probably the best one to show you is the last one because it's the one that I have up here as an example. So I asked it once upon a time in a galaxy far, far away. And then we can see that the output here is once upon a time in a galaxy far, far away. There lived two friends, Jack and Jill. They're very happy together until one day they had an argument about who was best at playing basketball. Jack believed that he was better than Jill because his dad owned all of them while she only played with her brother's ball. However, Jill argued back by saying that just because someone has more resources doesn't mean that they're automatically superior to others, and we could read through the story. But we can see it's a generally coherent story, a children's story. So Tiny Stories, 33 million parameters. It's trained on vocabulary up until I think like second grade, like kindergarten through second grade. So that's its vocabulary level essentially. So that's what the model gets to work with, what Phi gets to work with going in. And then Phi is like a very textbook heavy model, trained all on textbooks, and then its standard outputs are like it tries to output like textbook examples essentially. And then so I thought it would be interesting to pair these two models to see what would happen. And then oftentimes what will happen is that the Phi model will produce like more educational results. Like here's a good one. I asked it like, what's a measurement? And then of course the Tiny Stories model replied, and then it cleaned it up. The little girl smiled and said, it means how tall. I can see how tall you are. That's right, the teacher replied. Measurement helps us understand things better by giving them numbers. She then showed him a ruler that had inches on it. She explained to him that an inch meant 1/12 of an inch, well, 1/12 of a foot, or about 2.54 centimeters in length, which is accurate. The boy was fascinated. He wanted to know more about measuring other objects too, so he asked his mom if she could help him measure some fruits at home using different using different units like grams and ounces. His mother agreed happily as they went back inside. What we can see here is like coherent educational text and geared towards educational text, and then the model tries to do that in this instance, but always keeping it in stories, like it's really story grounded. And as I was iterating before, like this blend, see, I would get oftentimes outputs like this where the Phi model is just trying to output like more textbook style, but it's gotten with this iteration a lot better at kind of just like weaving in what it wants to talk about, like the fascinating world of math measurement, into like stories. It's more fluid in its text in that way. And then just to give you an example of what Tiny Stories is actually producing, so this is Tiny Stories, and this is a 42 million parameter model. So this is actually like a little bit more powerful than the assistant model that I'm using here in BartPhi. And then the same prompt, like once upon a time in a galaxy far, far away. There's a little boy named Tim and wanted to go some word. He very and wanted to explore world. He today so decided to go a advently. So in some word set of away. So it's generating text, not coherent text. Oftentimes not actually English. There was a little girl had a very place wanted to go a far farmost planet. She too and wanted to visiting that. A lot of butter. It likes butter a lot, so it'll say butter a lot, like butter. But so this is like the outputs. There's another butter. To her was to her, of course, butter. But so you can see that that's the initial output. If we were just running like the Tiny Story 33M, this is what we would be getting and generating. But so we can see this text compared to what we're getting over there on the other side, significant improvement. But so the model is still grounded because it still has to take that initial text, and I limit the tokens of that initial input so that it has like something to work with. But essentially it's grounded in that initially, and then so the model is working with that, and then from that, and then so what it ends up producing kind of is like a really interesting model for like people that are probably within that age bracket, like that kindergarten through third grade, because all of the text, all of the outputs are geared towards that level, very specifically because it has to be like the model's grounded and like the Tiny Stories model, everything is passed back through it multiple times. So it's interesting how this model works. It actually has utility. It significantly cleans up the stories of Tiny Stories, and then so if you want a model that can produce like early elementary school style stories, and is kind of built from the ground up specifically for that, then this is a model for you. If you're looking for within that same age bracket, like something that could be like possibly educational, that is a very low likelihood of producing any sort of harmful content whatsoever, then this is a model worth exploring, particularly possibly within that field. I think it's interesting. I didn't set out to make I wanted, my goal was to iterate on this until it was like actually something useful, and then this is the actual useful result that came out of it. I'm glad that it came out kind of like for like the educational space and like for early childhood development type space, if it's useful in that area at all. But it seems to me that it is. But I'll leave the description for the Colab link here, and then on my end, I'll probably work towards BartPhi 3.0, which will utilize a different architecture on the back end than Tiny Stories. So this will be kind of like probably the end of my Tiny Stories plus merging of Phi 1.5 for a little while. I might come back to this though, because I'm definitely intrigued by the output and the results of this. Like it surprised me how well that these two models have blended together. And the overall goal, I wanted to build an LLM model, like a functional LLM model that could be considered an actual model, and build it all in Google Colab, and then have it all run in Google Colab in a free Google Colab environment. And so goal achieved. Hope you like this video. Please like and subscribe. Thank you.